Thank you for joining us on the virtual tour of Kalingya Karunanidhi Institute of Technology, Coimbatore.
Hi, this is Pradeep from Kalingya Karunanidhi Technology, Department of Ethical and Advanced Engineering. Today we are going to see about separation of nodal losses on single phase transformer. So here the motor is coupled with the alternator. The input supply is electrical supply. The motor converting electrical supply into mechanical supply. The mechanical supply is given to the alternator, and finally the alternator converting a mechanical energy into electrical energy. So this is the nameplate details of the DC shunt motor coupled with the alternator details. So this is circuit diagram of the separation mode of single phase transformer. The motor is coupled with the alternator. Okay. So the connections are given as per circuit diagram. This one is a field rheostat, so 300 ohm rating, and this one is a potential divider. This is a DC field ammeter. This one is a voltmeter. This one is a lagging power factor meter. That means watt meter. This one is a frequency meter. This one is a step down transformer. So primary is 230 voltage and the secondary is 115 voltage. Okay. Now we are going to switch on the supply. And the motor is started by 3-point starter. 3-point starter. Separation of losses, that means the ADM losses in series losses. While connecting transformers, there are different types of losses are occurring. So one is iron loss and coal loss, and as well as discrete loss and also ADM losses. Okay. So here the ADM losses and the discrete losses are obtained by varying the frequency. By varying the frequency will be varied by varying the field rheostat. By varying the field rheostat, we can set the rated speed. Okay. Before that, we need to set the rated voltage of the transformer. That means alternator. So this one is a potential divider. By varying the potential divider, we can set the rated voltage. The rated voltage will be a 230 voltage. The rated voltage will be a 230 voltage. So by varying the potential divider, the voltage will be varying. So gradually, the voltage will be varying. Now we can set 115 voltage. So 0 to 150. So we can set 115 voltage. The multiplication factor is 2. Now it is 230 voltage. Now the motor speed is already we seen, so 1260 rpm. Now the frequency will be below 45. Now the frequency will be below 45. So by varying the field rheostat, the speed will be increases. By increasing the speed, the speed is 1272 rpm. The speed is 1272 rpm. The fluctuation will be occurring in the frequency meter. The fluctuation will be occurring in the frequency meter. Now the frequency is approximately 47. Now we can note the speed. Now the speed is 1390 rpm. 92 rpm. And we can note the field current and as well as voltage and as well as watt meters. Okay. And again we can vary the field rheostat. Now see, the frequency will be 49.5 Hz. 49.5 Hz. Again we can check the speed. Now the speed will be 1456 rpm. 1456 rpm. And again we can vary the field rheostat and set the 50 Hz frequency. Set the 50 Hz frequency. Now see, come close. Now see, the frequency will be 50 Hz. Accurately 50 Hz. Now the speed will be 1500 rpm. The speed will be nearly equal to the 1500 RPM. It is nearly 1500 RPM. So from the formula, we know the NS equal to 120 F by P. This is a synchronous speed formula. Here 120 is a phase sequence and F is a frequency and P is a number of poles. Okay, therefore here the 120 into, now we are getting a frequency is 50 Hz while the speed is 1500 RPM. Now the frequency is 50 Hz and the number of poles. Here the motor is a 4-pole motor. Then we are getting a 1500 RPM. That is the synchronous speed of the motor. Okay, so by changing the frequency, we can change the speed, and also we can change the speed, we can change the motor frequency. Finally, we can obtain this graph. So from this graph, we can calculate the constant value. K1 and K2 is the constant value, and also the Wi is the iron loss, and also from this formula we can calculate the series losses and also the eddy current losses. From this experiment, we can easily calculate the eddy current losses and the series losses. Thank you.